Hello students, I hope you're doing well and the first lesson was helpful and you could do your homework and the other assignments with no problem. So let's talk about rational exponents. So let's begin. So let's start. Let's start with from where we came up with the formulas that I'm going to enumerate. So let's say we have x equals 7 to 1/3. Let's say we have this equation, if you want. If we raise both sides to third power, we have x equals 7 to 1/3, and I want to raise each side to the third power. Well, what's going to end up on the left hand side? X to the third, and on the right hand side is going to be 7 to 1/3 times 3 based on the properties a to the n to the m equals a to n times m, which we've seen in the previous lesson. So we get x to the third equals 7, right? This means that x is a number whose cube is 7, which means x equals cube root of 7. So basically, if we compare the x that we started with the x that we ended up with, we can actually conclude that 7 to 1/3 equals cube root of 7. So basically, be very careful. What's going on here? What's the connection? Well, I can write this 7 to the first power. So basically, the denominator of the rational exponent is the same with the index of the radical. And the numerator of the fraction is the same with the power of the number under the radical. So let's look at some formulas. 1, a to 1/n. Well, if you look at the example above, or you can pause the video and try to figure out on your own. Okay, welcome back. So it's n root of a to the first, or just a. The second formula, a to n/m. So basically this time I don't have just 1 at the numerator, I have n, is going to be m root of a to the n, or it can be written m root of a to the n, like that. So they are the same thing. So again, the denominator is the same with the root. The denominator is the same with the root, you see. Okay, and one more, a to negative n/m. Well, when we have negative exponent, we are going to transform it into positive exponent by writing 1/a to n/m. So it's 1/m root of a to the n. Again, the denominator, it's the index of the root. So basically, I can say that in general, if I have n root of a, this n is called index, this is root, and a it's called, well, the number under the root, radicand. Just to have the vocabulary. So let me do a few examples. So it says use radical notation to simplify. Example 1, 100 to 1/2. So right now it's written in rational exponents. So in radicals, it's square root of 100. This would be 2 here, but we don't usually write it. So you can see mainly something like that. Well, square root of 100, we already went over that. It's 10, because 10 to the second is 100. Another example, negative 64 to 1/3. Well, written in radical notation, it's cube root, right? You see the denominator is 3, the same with the index. Because I have negative 64 in parentheses, the whole thing is going to be under the root. So what number raised to the third is negative 64? That would be negative 4. Another one, negative 81 to 1/4. Written like this, so the difference between 2 and 3 is this time, I wrote 18, I meant 81. This time, just 81 is raised to 1/4. So basically, this negative that it's here is just going to be copied because it's not part of the base of the exponent. So it's 4th root of 81. So 4th root, because this index here, the denominator is the same with the index. So now negative, I just copy it. Well, the hardest part is just getting these colors. So 4th root of 81, what number raised to the 4th? It's 81, 3. So the negative that I marked with green, it's actually just copying it, is not part of the exponent. While in example 2, the negative, it's part of the base of the exponent. Why? Because it's in parentheses. 4. Another one says use rational exponents. So basically it's exactly the opposite of what we just did. Now I have square root of 7 and I want to write it as rational exponent. 7 to 1/2. From where 1 and from where 1/2? Well, it's to the first, and then this index it's 2. So that's how we ended up with 1/2. 5. 3rd root of 5, the same thing. Here is to the first power. So it's going to be 5 to 1 over, you can pause it and you can do your own, 3, because the index and the denominator is the same. Another one, 6. 5th root of x to the 2nd y. So x to the 2nd y, the whole thing is raised to 1/5. Now from where I came up with 1, because this whole thing I can put it to the first power. From where I came up with the 5, from the index being the same. But we learned a few properties of exponents, so it's going to be x to the 2nd everything to 1/5, I can distribute, and y to 1/5. So if we do the computation, it's x to 2/5 times y to 1/5. So there you go, it's in the simplest form. Another problem, 2x cube root of y squared. You see, I was very careful with the cube root so that you don't confuse it with the power of x. So when you make your index for the radical, make sure you put it in that v place. So 2x, I just copied, is not raised to anything, is not part of the radical, times y. Well, the important numbers are the 2 and the 3. The 3, because it's the index, is going to be the denominator, so 2/3. And that's it. Okay, a few more examples. So let's say 8. It says rewrite the exponents using radicals. So for example, you have 49 to -1/2. So this would be 1/49 to 1/2, which is square root of 49. So it's 1/7. So we could simplify it. So you see, 49 to -1/2 wouldn't make any sense, right? But simplifying it using the positive exponents and radicals, it makes more sense. Another one, 9 to -1/2. Again, we transform it into positive exponents, and then we transform it into radicals, and we get 1/3. One more, 2xy, everything to -7/10. So as you can see, because of the parentheses, this whole thing is raised to -7/10. So first thing, I'm going to write 2xy to 7/10, and then I am going to use the radical, so 10th root of 2xy, everything to the 7. And I'm just going to leave it like that. Maybe some of you ask, well, what if it was 2 xy to negative 7 over 10, right? What would happen in that case? Well, if you think about it, the only thing that is raised to negative power is xy. 2 is by itself, is not raised to any power. It's just 2 times a quantity. So I'm just going to copy that 2, and then I'm going to change just xy to negative 7 over 10 as 1 over xy to 7 over 10. So 2 times 1, right, because I can do fractions, right, so multiply fractions, and then 10 root of xy to the 7. And that's pretty much it. So I hope you can see the difference between 10 and 11. Okay, a couple more problems. It says simplify. So 3 to 3 over 4 times 3 to 1 over 4. How would we compute this? Well, when I see this problem, it reminds me of a to the n times a to the m, which is a to n plus m. So then in our case, it's copy the base and add the two exponents, which is 3 to 4 over 4, which is 3 to the first power. So that's it. Another one, 2y to 1 over 5, everything to the fourth, over y to 3 over 10. So we raise each of them. So first I'm going to distribute these 4. So it's going to be 2 to the 4, y to 1 over 5, everything to the 4. The reason why I distributed is because of the formula a times b, everything to the n. It's a to the n, b to the n. And I had the parentheses. Y to 3 over 10, I didn't distribute the 4 at the denominator because the only thing that is raised to the 4 is this quantity that I highlighted with blue. So 2 to the 4 is 16, and then y to 4 over 5, because I used the formula a to the n, everything to the m, it's a to n times m, over y to 3 over 10. Now, these two remind us of what formula? Try and think about it, pause it a bit, try to do it ahead, and welcome back. So a to the n over a to the m, copy the base and subtract the exponents. So 16 times y to 4 over 5 minus 3 over 10. Well, we don't have the same denominator, so I am going to multiply this by 2 over 2 to get the denominator. So 16 times y to 8 minus 3 over 10 is 16 times y to 5 over 10, 8 minus 3 is 5, so it's 16 times y to 1/2, and it's written in the simplest form. Okay, one more thing, because it's very important. So for example, what if you have square root of x to the 4th? How do you simplify that, right? So there is a 2 here, right? So we write x to 4 over 2. I change it from radical into rational exponents, and it becomes x squared. And if you remember last time we had the conversation about absolute value, because you want to make sure, because of this index being even, you get a positive number. But x squared, it's a positive number all the time. Another one, 10th root of x to the 2nd. So it's x to 2 over 10, which is x to 1/5, or 5th root of x. And one more, and that's all for today. 4th root of a to the 5th, b to the 5th, over square root of ab. Well, we can write a to 5 over 4 times b to 5 over 4 over a to 1 over 2 times b to 1 over 2. So from where I got the 2? From here. Even if we don't write it, we know it's a 2. And the 1s from the fact that if I write just a, I know it's a to the 1st. So this one now, we copy the base and we subtract the exponents. So 5 over 4 minus 1 over 2, and then b, 5 over 4 minus 1 over 2. Well, we need to have the same denominators, so I'm going to multiply the second one by 2 over 2, because they are identical. So we get a to 5 over 4 minus 2 over 4, that's 3 over 4, and b to 3 over 4 as well. So basically we have fourth root of a to the third, b to the third, and that's the simplest form. Well, I hope this helps you. We'll hear each other, or maybe you'll hear just me, next time.